We begin our chapter review with some division. Now when you're doing polynomial division, remember that there are two processes. If you're dividing by a monomial, you will create separate fractions, but if you are dividing by a binomial, you must do long division. Do not cancel in this problem as you see it directly. If you do know your cube formula, you can factor this numerator into x plus 4 times x squared minus 4x plus 16 and have x plus 4 down below, and you can cancel and have the remaining factor there as the quotient. But if you don't spot that, then you would need to do some long division here or synthetic division, which I think is actually a little bit better here. We have 1x cubed, no x squared, no x's, and 64. We're going to change the sign of that 4 to a negative 4 as part of our synthetic division process. Bring down the leading 1 and begin this multiply and add process. Negative 4 times 1 is negative 4, and adding down we have negative 4. Multiplying we have 16, add down we have 16. Negative 4 times 16 is negative 64, add down and get 0. We knew we'd have a remainder of 0 because up above we saw that it factored cleanly. We began with an x cubed, so now we have x squared minus 4x plus 16, which is consistent with what we did using the cube formula method of factoring. When you are dividing by a monomial such as 15x cubed, it's a lot easier just to write this as separate fractions, put a 15x cubed down beneath each one of them, and then simplify each fraction separately and have your solution. So in this first fraction, x cubes cancel, but you will have 5 over 15, which reduces to 1/3, plus what appears to be 2/3 with an extra x down in the denominator, minus 1 over x squared, plus 20 over 15 reduces to 4/3, so 4 over 3x to the third. And that is the solution. Now I use the direction of simplify on this next problem to not remind you that this was multiplication, because the common mistake is to square each term inside. Instead, you want to write this as 3x minus 2y times 3x minus 2y again, and do all the distribution out. The first part of the distribution, 3x times 3x, is 9x squared. The two outer terms, 3x and minus 2y, give you minus 6xy, as do the inner terms, negative 6xy, and the L part of FOIL would be plus 4y squared. When you combine these two middle terms together, you get a final answer of 9x squared minus 12xy plus 4y squared. Now after you've done so much distribution and foiling, when you see these two parentheses here, you tend to overlook the plus sign and want to do foiling. Instead, all you're going to be doing is adding like terms for this addition problem, and that's going to give you 7x plus 1 as the solution. When you are subtracting, you always have to be careful of the order. Technically, you are beginning with the x squared minus 9x minus 11, and from it you are subtracting the 3x squared minus 4x plus 8. So that's one place you could make a mistake here. The second one is that of distribution of the negative, which is a common error. We really don't need the parentheses around this first polynomial any longer, so I will drop them off. And distributing the negative, we have negative 3x squared plus 4x minus 8. Now we can combine each set of like terms to get our solution, which will be negative 2x squared minus 5x minus 19. Since we are multiplying binomial times binomial, the FOIL process works. The first term of FOIL would be 6x squared. The outer term, 3x times minus 7, would be minus 21x. The inner term would be plus 10x. And the last term, 5 times negative 7, makes negative 35. Combining these middle terms together, we have 6x squared minus 11x minus 35. We cannot use the FOIL process for this problem because there are 3 terms in that second parentheses. Instead, we should take the x and distribute it from the first parentheses to each thing in the second parentheses, giving us x to the third plus 5x squared minus 3x, and then distribute the negative 4 times each term in that second grouping, giving us minus 4x squared minus 20x plus 12. And notice how I aligned my like terms to make it easy to add down. And this will give us x to the third plus x to the second minus 23x plus 12. The next problem, the square of a number, okay, that would be x squared, is subtracted from 60. Okay, start with a 60, then minus the x squared, resulting in negative 4. Okay, there's our equation. Find the numbers that make this work. Well, I would like to have a positive x squared, so I'm going to bring each of these terms to the right instead. Have a 0 on the left equals x squared, and when I minus that 60 off, I'll have minus 64. This factors into the difference of 2 squares, x plus 8 times x minus 8, and all such numbers that make that true would be plus or minus 8.